in the passage we read below, Ptolemy considers an observer at the 36th parallel, that's the latitude of 36 degrees, corresponding, for example, to the position of the island of Rhodes in the Aegean Sea. Oh, it's in the Aegean Sea? Really? I thought it was in the Mediterranean. We need to take a look at this.
Yes.
So we'll type in Rhodes, and then, well, I guess we want to say maps, huh? Okay. And we can zoom out. Okay, so the Aegean Sea is a branch of the Mediterranean? Okay. So yeah, I sort of consider this to be between the Aegean Sea and the Mediterranean Sea. But yeah, so you can see there's Greece and Italy is just west of there. And yeah, modern day Turkey and whatnot. All right, so in the first part of our excerpt from the Almagest, Ptolemy sets up the geometric model of the gnomon within the celestial sphere and arranges his diagram. And so this is actually a reconstruction in English of the Almagest. So he says the required ratios of shadow to gnomon can be found quite simply once one is given the arc between the solstices and the arc between the horizon and the pole. And this can be shown as follows. What are we looking at here? So this is a meridian. Sorry, this is the celestial circle, and at the center of the celestial circle is the Earth. So then the line of the equator, well, it depends on where the North Pole is, right? So the Earth is sort of tilted here, so we're going to say the North Pole is off that way, right? Because the Earth is tilted, its spin is tilted inside the celestial sphere, right? So let's say that the North Pole, where do they draw it about here? Huh? So let's give that a name like C for North Pole. Actually, I use C because it's not used in any other, as in any other point is not labeled C. It goes what? A, B, and there's no C, okay? So it goes to D, all right? So I've got a straight line there. Okay, so the equator then is going to be perpendicular to the axis, right? So we can make that a right angle there. And that's where the, which of these lines is then the equator? That's going to be BZ, BD? Yeah, so that's where the equinox occurs, right? It's on the equator. So this would be the line extended through the Earth at the equator, right? So, I mean, we're looking at this as sort of the celestial sphere, but then we're extending the various parts of the Earth in that context, right? So the Earth is at this angle here, pointing to the North Pole there, and the equator then would be this line BD. On the equinox, the sun is at its highest point at the equator. This would be the summer solstice and the winter solstice, right? So if you're on the northern hemisphere, then your horizon is going to be this line here. So suppose you're at Rhodes, then this is the horizon line. Do we have a label for that? We don't, so let's use the letter F, that's free. So this is the horizon. Okay, so this angle here would be 36 degrees if you're at Rhodes. The angle from the horizon to the North Pole is an indication of your latitude. So this is then the equator line, and this is going to be the equinox here. the sun is highest in the sky at the summer solstice. Summer solstice, and equidistant on the other side. And so how are these points labeled? This is BHA. Oh,
No.
Isn't it
LB.
LBHA?
oh, sorry.
So equinox is B.
So this is the lowest and the highest. Okay, L for lowest, H for highest, and A is the point directly overhead. So if you're standing on the Earth, the point directly overhead is perpendicular to the horizon, right? So this is also perpendicular here. Right? So we have two right angles. The right angle that the axis of the Earth makes with the horizon, and with the equator, right? So the North Pole and the equator meet at, those lines meet at a right angle, and then your zenith is perpendicular to the horizon, right? So A is the zenith, that's the point directly above your head if you're standing on the Earth. So you're like here, standing on the Earth, right? And the zenith is directly above, and the horizon extends horizontally, perpendicular to the zenith. And okay, so this line here is the line of the summer solstice. That's the highest that the Earth is above the horizon, and the lowest that the Earth is above the horizon is this point L. So these two are the same, right? And that's in fact the angle of obliquity. Okay, so we have this line, and so these points are also labeled theta dm. And we draw this line down here parallel to the horizon line. Because we're kind of thinking of the gnomon as this length GE here, right? So if you stick a stick in the ground, it's going to be parallel to this line, right? So you can kind of imagine that this is your stick stuck in the ground, which is parallel to the horizon, right? And so if the sun is at the summer solstice, it's going to shine on this stick and make this shadow here, which is GK, is it? Yeah. If we then extend this line, we'll see that that's the shadow
Z.
of the equinox. And if we extend this line here to N, is it?
Yes.
Okay, that's